Hello. Today we're working with creating and solving compound inequalities. The word compound means more than one. So a compound statement is formed by combining two or more simple statements. A compound statement can be true or false. A compound statement involving the word and is true when both simple statements are true. A compound statement involving the word or is true when either one simple statement or both are true. And basically it just comes from lots of practice with these. So solving compound inequalities involving the word and. Combining two or more simple inequalities forms a compound inequality. The graph of a compound inequality involving the word and is the intersection or the overlapping region of a simple inequality graphs. Okay, and so some of the words that all real numbers greater than 2 and less than 6 can be written like this. X is greater than 2 and it's also less than 6. We can also write it as 2 is less than X and but X is also less than 6. And when you graph it, it is only the section between 2 and 6. And you'll notice that they are open circles, meaning that it doesn't equal 2 and it doesn't equal 6. But any number that can be found on the number line between the two are solutions to this inequality statement. This one is all real numbers greater than or equal to 2 and less than or equal to 6. So now they've included these or equal to, and the only difference is that it is a closed circle on each end and including all numbers in between. So it can be 2, it can be 2.5, it could be 3.25, it could be 4.78, all the way up to 6. Any number found between these two plus these two is a solution to this inequality statement. So now we're going to solve a compound inequality and we're going to graph the solutions. So our inequality statement is 4 is less than or equal to x plus 2, which is less than or equal to 8. And what we can do is we can break them up into two separate ones by taking the first half and then doing the second half. And this what's this one here. And we can solve those by determining which work. So I'm going to write it off to the side. It makes it a little easier to keep track of here. So we have 4 is less than or equal to x plus 2. Just as we've done before, we're going to reverse operations. And so 2 is less than or equal to x. Our other one is x plus 2 is less than or equal to 8. We're going to subtract 2 from both sides. X is less than or equal to 8. So what we have found is that 2 is less than or equal to x, and x is less than or equal to 8. So when we graph those, if we have 2 is less than or equal to x, I'm going to change my color here. So 2 is less than or equal to x. So that means x can be 2, but it can be all the numbers that are greater than 2 as well. We could also rewrite this by doing a flip of everything, where everything reverses order. The x and the 2 switch places, and the less than or equal to becomes greater than or equal to. I sometimes refer to this as a pancake flip. This one here is x is less than or equal to 6. So we find 6, and we graph that, and x is less than, so it's everything to the left. And the overlap section is this right here. So that's why the solution, when graphed, goes from 2 to 6 and everything in between. There's another way that we could do this without rewriting the sections into two different sections. We can leave them as one. So if I have -5 is less than or equal to 2x plus 3, which is less than 9, I can take and I can solve it from here. Just remember, what I do on one side of the symbol, I have to do on the other side of the symbol, regardless which directions so I'm doing it to everything. So in this case, I'm going to subtract 3 to move it from here, because my goal is to get this x by itself. So I'm going to subtract 3, subtract 3. It's gone here. -5 minus 3 is -8. Bring down my symbol, bring down my 2x, bring down my symbol. 9 minus 3 is 6. Now I'm ready to divide everything by 3, or by 2. Excuse me. -8 divided by 2 is -4. 2 divided by 2 is 1, so it's x. And 6 divided by 2 is 3. I moved a positive, so my symbols all stay the same. And so I just bring them straight down, okay? Doing this is the same as doing this. It's just in one section instead of two separate sections. Now we're ready to graph them. And so we have -4 is less than or equal to x. So that means x is going to be any number greater than -4. So we're going to find our -4, and it's closed. And it's every number greater or equal to -4. But x is also less than 3, so we're going to find 3, and it's less than, so it can't be 3, but it can be every number in between. Now the overlap is here at -4, which is a solid circle, and at 3, which is a hollow circle, and then everything in between. Okay? So this is your answer in mathematical, and this is it graphed. We can solve each inequality and graph the solutions. So I have -2 is less than x minus 3, which is less than 5. And I'm going to solve by adding 3 to each side. And remember, I have to do it to each. Since there are 3 sections, I have to do it 3 times. This is gone. Bring down my x. 5 plus 3 is 8. And -2 plus 3 is 1. I did not multiply or divide yet, so signs just come down. I don't have to do anything else because x is by itself. So x is greater than 1. So it's greater than, so which means it's hollow. And it's greater than 1. And it is less than 8. And then because it's also going to go to 8 but not equal 8, we're going to put a circle on 8. And then everything in between gets a line. Okay? Then we have -10 is less than 3x plus 2, which is less than or equal to 8. So we're going to solve for x by moving the 2. And again, there's 3 sections, so we're going to do this 3 times. And we have 3x. Go ahead and bring down my symbols. 8 minus 2 is 6, and -10 minus 2 is -12. Divide everything by 3. I'm moving a positive, so my symbols won't change. 6 divided by 3 is 2. -12 divided by 3 is -4. So when I'm doing this one, my x is greater than -4. So it is open because it's greater than. And x is also less than or equal to 2 because it's or equal to. This is a solid circle. And then a line drawn between the 2. Now, if this had been a -3, these symbols would have reverse directions. So just remember, that you want to double check to make sure that when you're multiplying or dividing that it's a positive or a negative, because if it's a negative, you're going to make changes. Okay, and I believe that is the end of part 1. Come back and see me for part 2.